Okay, we are moving on to 10.7. And it is the section that's going to be on surface integral. Okay, so similar to line integral, there are two kinds of surface integral. First one is the surface integral of scalar function. And then remember, this function here is gonna be a function of x, y, z because we're moving up to one variable, right? So fx, y, z, and then well, surface integral of vector field f x y z. Today we're gonna focus on a surface integral of scalar function. Okay, well, I'm just gonna go from the line integral to the surface integral, and that way it is faster for you guys to see. So here come line integral, right? C fx y ds. So this one you can see as the length, and then this one is the width. So together we have a area, and then you do this, you get the area of curvy wall fence. Okay, so here come the surface integral. This double integral over the surface S. F, well, we're moving up to a dimension as it's going to be x, y, z. The reason why fx, y, z because in the line integral, right? C is the domain of fx, y. So for the surface integral, S must be in the domain of fx, y, z. fx, y, z is the family of surfaces. And here come ds. Okay, what is this fx, y, z here? Well, most of us know this as density. Well, surface is just area. So ds is going to be area. So density times area. What we have is, well, is mass And then if we sum the mass all over the surface, then it's going to be a mass of a thin surface. Parameterize the surface, and this would be double integral over the region D. We parameterize it. So fxyz is f of the vector or uv. Yeah. And then ds is gonna be, well, what we have from last time is the area. That is the cross product or u and or v, or u cross or v dA. Okay. Parameterize C. Oh, well, you get something similar. And you're going to integrate this one from A to B. And this F of or T. Well, ds is the, it's not going to be the area, it's the width. So that is the square root of dx over dt square plus dy over dt square and dt. Yeah. Some similarity there. This vector, a vector that parameterize curve C. And then so this vector right here, this a vector. It's a vector function. it's not just a vector function. So yeah, dx over dt plus the dy over dt, that one is just ds. Because we proved it last time. If you look at the previous section from 16.2, you see that, oh yeah, we did the ds right here. Yeah, it's the ds right here. Yeah. And for this one, for the this ds area, right? We did it last time because in the previous section we compute the area of this one. It's the area right here. This is the sample area. See, it's just the area of the parallelogram formed by the two tangent vector. Special case. That is the, if you can parameterize s using x equal x, y equal y, z equal f, x, y, then the surface integral is gonna be fx, y, z ds. That this is, well, double integral over the region D. X, y. Oh man, I'm using f here again, and I guess this fx, y, z is just gonna be using g here. Fx, y, g, x, y. ds here, if you guys remember from last time, that is square root of gx square plus gy square plus 1 dA. That's the special case from last time. Computer math. a surface S that is part of the plane two x plus 2y plus z equal 4 in the first quadrant, in the first octane. Give the density of the surface is the fx yz equal to xz. Here, you guys should not have any trouble with this thing. It's pretty simple to sketch too. We can like go over this one together. Okay, 2 to 4, so 2 to 4. Yeah, this is the this is the surface right here, the region D. Project it onto the xy plane, get a region D. Okay, so x equal x, y equal y, z equal to fxy. Yeah, that is going to be a 4 minus 2x minus 2y. Yeah. Double integral. It's the surface integral. Fx y z ds. That is the mass right here. So this one, we're going to parameterize s. Double integral over the region D. And then when we parameterize s right here, well, we have it to be fx y z, right? Is x z, but we know z is 4 times 4 minus 2x minus 2y. So this is x, 4 minus 2x minus 2y. Okay. And then the ds is gonna be, well, if you notice that is the special case there, I'm trying s special case. It's gonna be a square root of fx square, so minus 2 square, fy square minus 2 square plus 1. Now let's take care of this one here. This is the square root 9, so it's gonna be 3. Huh? I'm gonna pull out the number 3 outside. D, right? 4x minus 2 x squared minus 2 xy dA. Okay. Region D is not a rectangle, right? It's the triangular region. So you can either do a dA to be dx dy or dy dx. Up to you. Doesn't matter. So I'm gonna do dA to be a dy dx there. Just okay. If you look up here, y, it's go from here to here. See, yeah. Y go from 0 up to that line, and then that line is the 2x plus 2y equal 4. So write this out here. This is the line. Oh man. Zero to 2 minus x, and then x just the outermost integral has to be number, so x gonna be between 0 and 2. And then work it out, should be that bad. Okay, what do we have? We have a ax minus 4x squared minus 4x squared plus 2x to the power 3 minus 4x plus 4x squared minus x to the 3. Oh, dx there. Oh man, what this thing is. So we have x to the 3 minus 4x squared, and that look like plus 4x. Woo, almost there. X for 4 minus 4 for 3 x3 plus 2x squared okay 4. I make your life easy here, just compute. I compute this one where S is the surface y equal to x squared plus 4z bounded by the plane x equals 0, x equal 1, z equals 0, z equal 1. Parameterize as according to this one, you can let x equal x, that z equal to z, and then y is fxz or gxz. I'm just going to write gxz here. Is the x squared plus 4z, right? Slightly a little bit different, right? And then from here you see that, oh man, you also get to know the region D, where 0 less than equal x less than equal 1, 0 less than equal z less than equal 1. How nice, even though you don't know how to sketch the surface. Okay. The next step is that you got to, twist that formula a little bit. Right? Okay. I'm gonna s x ds, right? We still have to parameterize s, but this is the special case here. Special case, then just a little twist here. Right? Okay, so double integral over the region D x, and then the ds here is gonna be a root up, you say this one. Right? Actually, let me take you guys up here. When you have x equal xy equal yz equal gxy, the ds is gx plus gy squared plus 1. Okay? So in this case, you're gonna have to twist that special case a little bit. It's gonna be a gx squared plus gz squared plus 1 dA. Everybody okay, right? Just a little twist there to the special case. And from here, well, I'm gonna do the setup because if you look at the region D, right? This tells us the region D. This is the D region D right here. Huh? 0, 1, 0, 1, x, the root of gx, so 2x squared gz 4 squared plus 1, 1. Okay, so you get 8, right? The 1 over 8. And then 1 over 2 plus is 2 over 3, u 3 over 2, 4x squared plus 17, 3 over 2. Okay. What do we have here? We have a 1 over 12. 4 times 1 is the 4 plus something is 21. 3 over 2 minus you plug in the 0 in here, you get 17. 3 over 2.